Hi guys, you are welcome once again to the Smart Way lectures on the Science Ambassador series. This is a series of lectures we are running on all the areas in science, and today we are here with you to continue on chemistry, that is inorganic chemistry. In our last video we talked about how we can use the percentage composition of each element within organic compound to find for the empirical formula of a compound. We said that empirical formula is the formula that shows the simplest whole number ratio. That is the simplest whole number ratio of each atoms of the element present within the compound. Okay, so now today we are going to take our time to really take you through all the chemical formulas that we have, and then we are going to talk and compare. Okay, we are going to compare them for us to really understand them, okay, very well. And so the empirical formula, molecular formula, and structural formula, okay, are all under what we call chemical formula. They are all under chemical formula. So they are all under chemical what? They are all under chemical formula. Now, what are chemical formulas? That's what somebody will say. What are chemical formulas? Now, in science and in chemistry, when we say a chemical formula, we are talking about a way, or a way of representing a compound. So we are talking about a way of representing a compound, a way of what? Representing. We are talking about a way of representing a compound. We are talking about a way of representing the what? Way of representing a compound. Okay, so a way of representing a compound. Now, in this representation, what we do is that, we use the correct, chemical symbols. We use the correct chemical symbols. We use the correct chemical symbols of each, of each element, or the various elements, that combined in the compound, that combined within the compound, or that is found within the compound. That is found within the compound. Now, within this representation, there is also another information. That information is that this chemical formula also shows the relative. It also shows the relative. Shows the relative amount. Shows the relative amount of the various elements, of the various elements, within a compound. Now, let me take you for example. Now, if I have carbon, for instance, combining with what? Oxygen. Now, how do I represent it? I'll go and represent it as what? The correct symbol for this is C, and the correct symbol for this is what? Is O. And so when they combine in proper terms, we are going to get carbon dioxide. We are going to get carbon what? We are going to get carbon what? Dioxide. We are going to get carbon dioxide. And in carbon dioxide, the correct chemical symbol is this, and this. This, that, and that. Now, in true terms, what it means is that a certain quantity of carbon dioxide combined with a certain quantity of oxygen. Now, how many elements of carbon dioxide combined? That is one here. And then how many here? We have what? Two atoms here combined. So we have in here there is a gas, so we have to represent it as a molecule here. So you can see that a certain quantity of what? Carbon dioxide combined with a certain quantity of this, and this gives us what? The two of them combined to form one compound. So this is a compound. Now a chemical formula will show us a way of representing. It is a way of representing the compound, okay? It's a way of representing the compound using the correct chemical symbols, showing us also the relative amount of each of the elements within a compound. Here we can have, I said, we have one atom, okay, of what? We have one atom of, we have only one atom, okay? We have one atom of carbon, okay, that combined, and here we have two what? Atoms of what? Oxygen. Have you gotten that? Two what? Atoms of what? Of oxygen, okay? We have two atoms of oxygen. Now these numbers, as I said, shows the relative quantities that of each element combined within a compound. So that is what we talk about chemical formula. So when you talk of chemical formula, it is an expression in true way, in true terms. It is an expression in terms of symbols, okay? It's an expression in terms of symbols. It is an expression in terms of symbols showing, okay, the various, okay, amount, or showing the relative amount of each element combined within the compound. So that's what we call chemical formulas. And in chemistry there are three types of chemical formulas. So there are types here, types here. There are three types, right? So there are three types of chemical formulas. There are three types of chemical formulas, okay? Three types. And the first one, as we said already, we have the empirical formula. We have the empirical what? Formula. Empirical formula. We have the empirical formula, okay? And two, we have the molecular formula. These are all different ways of representing the compound. So molecular formula. We have also the structural formula. We also have what we call the structural formula. The structural what? Structural formula, okay? We also have the structural formula. So there are three different ways of representing the compound. Now we are going to take each of these types so that we talk about them extensively. We are going to take each of these types so that we talk about them extensively. So let's talk about the empirical formula. Let's talk about the empirical formulas. Remember we said we have three types. Okay, we have the empirical formula. We have the empirical what? Empirical formula. We have the what? We have two. We have the molecular formula. We have the molecular formula, and then we have the what? The structural formula. We are going to first take the. We are first going to take the empirical formula. So let's talk about the empirical formula. Let's talk about the empirical formula. Now, I will do this by representing some various compounds here so that you can understand them very well. Okay. So let me give you a compound like this. Okay. Let me give you a compound here. C2H6. Okay. And let me also give a compound here, C4H what? H10 and C6 H14. Now these are compounds. So here we have this molecular formula. These are compounds here, and then we have what we call 1 and 3. We have 2 and 5, and then we have 3 and 7. Now these are formulas, okay? These are empirical formulas. When we say empirical formula shows us the very simplified ratio. It shows us the simplest whole number ratio. So it tells us the simplest, okay, tells us the simplest whole number ratio. It tells us the simplest whole number ratio of each atom within an element, or of each element within a compound. It shows us the simplest whole number ratio of each element or atom within a compound. Now this is what I've talked about. Let's take this. Let's take this and then explain them. Let's take this and explain them. Now when you take these two compounds, you can see that the C has, that is, we have 2 carbon here, and we have 6 oxygen, and we have 2 carbons, and we have 2 carbons and 6 hydrogen. Now, but this compound, we can further simplify this ratio, or this number. We can further simplify this number down there. Now this number can be further simplified. Now 2 can go into itself 1, and then 2 can go into here by by 3. Now in that, that means that there is 1 carbon, and here there is 3 hydrogen. And so this ratio this ratio is the simplest whole number ratio of this particular formula, of this particular compound. And the simplest whole number ratio that we can divide by dividing by a common factor. So when divide here by a common factor of 2 and 2, you get a simplified ratio to be 1 and 3. And that simplified ratio of each element within the compound is what we say that it is empirical formula. So this one becomes the empirical formula. So empirical formula shows us the simplest whole number ratio of each element or atom within the compound. Now let's take the next one. In the next one, we have 4 carbon, and then combined with 10 hydrogen. But this we can further divide them. We can further divide them. Here we can divide 4 by there's a common factor. 2 can go here, 2 can go here, so and here 2 can go into 4, 2 and 2 can go into here 5. And so the simplified number of carbon, that the smallest number of carbon that can be found here, is 2 carbon and then 5 hydrogens. Have you gotten that? 5 hydrogens. So this compound, we have further we have further deduced it into its simplified formula. And the smallest, that is the smallest whole number ratio that we can get out from a particular compound, is what we call the empirical formula. The simplest whole number ratio that we can obtain from a particular formula is what we call the empirical formula. Now the word empirical means in its Latin word truly, it means experimental. It's an experimental something. It's an experimental. Experimental. Now that empirical, remember in our lectures, after we run the experiment and we determine the percentage composition, we use the percentage amount. We use those percentage amount to strive for the simplest whole number ratio of the element within the compound. Now, so normally when we are in the lab and we are running the experiment, we don't really get this type of compound. We get the simplest whole number ratio of the compound. So whatever we get from the experiment are usually simplified. We don't really get the actual. We get normally the simplified, and then out of our mathematics we will get the actual. Out of our own deduction and this mathematics we will get the actual. So the word empirical simply directly comes from experiment. That means direct from experiment. And so from direct from experiment, normally the compounds comes in the form of its simplest unit or state. So basically that is why. So when you say empirical formula shows us the simplified whole number ratio of each element within a compound. Here we have 6 what carbon, okay, and we have 14 what hydrogen. This we can't further what strike it. 3 can go here, or 2 can go here, 3, and 2 can go here, 7. So the simplified, the smallest number of carbon that can be there is 3, and the smallest number of this one that can be there is what? Is 7. Now this formula is what we call the empirical formula. It tells us the very simplified number of what carbon and what and hydrogen within the particular compound, and hydrogen within the particular compound. So this is what we call the empirical formula. This is what we call the empirical formula. Now let's take the molecular formula. Okay, let's take the molecular formula. So let's take the molecular formula. What molecular formula is? Okay, what molecular formula is? Molecular formula. Molecular formula. Now in the molecular formula, this you can look here. Now in our first instance, I gave you 2 and 6, and which we further broke down or simplified to get what? 1 and what? 1 and 3. Okay, yes. So this formula is what we call the molecular formula. Let me change the color. This formula is what we call the molecular formula. The molecular formula. You can see that the molecular formula. Okay, F. Now we can see that the molecular formula shows us the exact or the actual. It shows us the actual, okay, or the exact, okay, whole number ratio. The exact or the whole number ratio. Okay, whole what? Number ratio. Okay, whole number ratio. Okay, it shows us the exact or the actual whole number ratio of each element within a compound, of each element or atoms within a compound. So it shows that the simplest whole number ratio of each atoms within a compound. Here we can see that in total we have 2 atoms of carbon, and here we have what? 6 atoms of what? Hydrogen. Okay, we have 2 atoms here. This is the actual. It is not a simplified version. It is the actual. It tells us the actual whole number ratio of that. Now in the earlier video, I told you that this is gotten when after we determine the molecular formula of the compound using the mass spectrometer. Okay, so we'll do that in our next video, that is by solving questions. Okay, so that is it. So when you say molecular formula is a formula that shows the exact whole number ratio, or it tells us the exact numbers of each, okay, atoms, okay, of the element present within a compound, okay, of each atoms of the element present in the total number of carbon is 2, and the total number of hydrogen is 6. Here it is a simplified one. So this is what we call the empirical formula. Empirical formula shows a very simplified, okay, ratio. It shows a very simplified ratio of each atom of the element within a compound. Of each atom of the element within a compound. Here you cannot say that this is the actual. Actually, the real number of atom of carbon is 2, and here is 6. But after doing some division, okay, we got what we call 1:3. So the empirical formula is different from molecular formula, okay, by what? By its what? A number of atoms that are there. Okay, by its number of atoms that are there. So basically that is it. Now let me give you broad examples of all, so that you can give. Now you can take an example. Let me write general. So we have a molecular formula this, and we can get what? 1:3. Okay, and let me give you this. Okay, so 3:8. Okay, now let's see, can we further divide this and this? Can we further break this thing down to, does it have a common factor? Can 3 go here, 3 go here? No. Okay, so no, that is not possible, and so there is no simplified ratio that we can get here. Okay, we can't further divide this one and this one by any number. Okay, so and remember, we don't want what? A decimal. We always want a whole number, and so this still remains the same here. So here this still remains the same. So 3 is to what? Is to 8. This is the simplest what? Ratio you can get. Further divisions will give you what? A decimal, which we don't want. Have you gotten that? And so some molecular formulas are the same as what? Empirical formulas. Some molecular formulas that cannot be what? Self-divided. Okay, it's the same as the what? The molecular formula, the empirical formulas. This is an empirical formula, and this is a what? Molecular formula. So let's go to what? The 4 and what? Let's go to 4 and what? And 10. And I said that here the simplest whole number ratio of carbon that can be there is what? 2, and that is the simplest is what? Is 5. That is when you strike this 2 against here, 2 against here, you get this to that. And you can't further divide 2 against 5 again. And when you have 5 is to say 12. Okay, when you say 5 is to 12, you can see that here, how many? Here, can we further divide this and this by a common factor? 5 and 12. 5 cannot go into this. 2 or whatever, nothing can go here. And so here, we will have the same repeating itself. Okay, so here, the actual become the simplest. Okay, here the actual, that is here, the actual become the simplest, or the molecular formula become the empirical formula. Now let's go to the last one, 6. Okay, let's go. So let's go to the last one. So we are going to get this. Okay, that is 14. Okay, is it 14? Yes, 14. Now, good. Let's check here. Here, can any number go here? Can 2 go here? 2 go here. 3 go here. 3 go here. 4 go here. 4 go here. Or 6 here go here. 6 go here. Here, the same number. So here, 2 can go here. 2 can go here. So you are going to get what? 3 is to what? Is to 7. Okay. So these are examples. So we have the molecular formula. We have the molecular what? Formula. Molecular formula. And we have the what? The empirical formula. One tells us the actual or exact. One tells us the actual or what? Exact. Okay, and one tells us the what? The simplified. That tells us the simplified, not really the exact. Not the exact, or the simplified, or the simplest. Okay, so basically that is what is the difference between empirical formula and molecular formula. That's the difference between empirical formula and molecular formula. I'll end this with the structural formula. I'll end this with the structural formula. So what is the structural formula? Now, what is the structural formula? Now, when you say a structural formula is a formula that shows how the various atoms are connected to each other. It shows how the various atoms are connected, okay, or are bonded. It shows you how the various atoms are connected. That is the various positions of the atoms, okay, the various positions of the atoms around each other, okay, various positions. So we can give you an example here. I can have here. Okay, so I can have this. So you can see here. Okay, so let me write the molecular formula for this. The molecular formula for this is how many carbon is here? 1, 2, so 2 carbon. And how many hydrogen? This is hydrogen, sorry. So how many hydrogen? So you are going to get 1, 2, 3, 4, 5, 6, 7. So that is 6 hydrogens. 1, 2, 3, 4, 5, 6. 6 hydrogen. 6 hydrogens here. Have you gotten that? So when you say structural formula will not just give you the raw numbers of atoms. It will not give you just the raw numbers of the atoms of the element. It will tell you how each of those atoms, okay, tells us how each of the atoms are arranged, okay, around each other, or are arranged. It tells you how the atoms are arranged. So you can see that here we have 6 hydrogens, and which are arranged around the carbon like this. So it tells you the various arrangement of the atoms around each other. Tells you how the atoms are positioned in space. or the spatial arrangement. Tells us the spatial arrangement. That is how the atoms are positioned, okay, within a space. Okay, so that is it. Then we can also have, let me write that of the alcohol. Okay, alcohol like this is this. Okay, alcohol like this is this. Is this. Okay, alcohol like this is this. Is this. Okay, so you can see, and its formula is 2 carbon and 6 what hydrogens and 1 what oxygen. So this gives us the actual numbers of each element, okay, within the compound. But here this gives us the how the atoms are arranged, okay, around, okay, each other. It tells you how the atoms are. So structural formula shows us how each atoms are arranged around each other. And so we can see how these are arranged, where the OH is attached to, where hydrogen is attached to, where how they are arranged in space. Okay, so that is it. So molecular formula just gives us the, it just gives us the what, the exact numbers, but doesn't show how the atoms are arranged. Let me draw that for water. Water like this, we know it is what, H2 what O. Okay, H2O. Okay, so we can have O. Okay, and we have this like that, and then what, like that. So this is how they are arranged. Okay, and we have the lone pairs over here. Okay, so here we have here, we can have so many of them. You can have so many of them. Okay, you can have so many of them. So basically that is the difference. Now let me quickly give the here we have already given the empirical formula already, so there's no need. Okay, there's no need of giving the empirical formula. So these are the 3 formulas that we have. So next time when you see a structural formula, you should know that it tells you how each atoms are arranged, okay, around itself. Okay, and how each atoms are arranged, okay, around each other. Okay, it tells you how atoms are arranged, okay, within a particular what a compound. Okay, so it gives us the spatial arrangement, or it gives us what to call how the atoms are connected with each other and where the positions that they are within the particular compound. Molecular formula tells you the exact numbers of each atoms, okay, within the compound. Empirical formula tells you the simplified numbers that are there. Now we will follow this in our next lecture. We are going to take questions to be able to find for the empirical formula and the molecular formula. We are going to find for the empirical formula and the molecular formula. Thank you.